All right, let's keep going here. It seems pretty obvious to me that we're going to do the left side. It's more complicated. And we're going to, because there's fractions, we're going to need to get a common denominator. What's interesting about this one is that the common denominator will also be the conjugate. This side will need this one, which is the conjugate. And then this side needs the other one. So I'm going to just rewrite this with a little bit of space. So sine x over 1 plus cos plus sine x over 1 minus cos. And then this side, the right, is going to need a 1 plus cos on both sides, or sorry, top and bottom. 1 plus cos. And the left side will need a 1 minus cos. And again, these are conjugates by chance. We just need to do a common denominator, which is that every denominator needs the opposite denominator. So this is going to be a sine x times 1, which is just sine x, minus cos sine. Cos times sine is just cosine. Cos x sine x. And then I'm hoping that you'll get pretty quick at multiplying these out. 1 times 1 is just 1. 1 times cos is positive cos. Negative cos times 1 is a negative cos, which will cancel out, minus cos squared. And because they're conjugates, those middle ones will be eliminated. The same is true for this one. So plus sine times 1 is just sine. Sine x times cos x is just going to be a sine x cos x, or a cos x sine x, maybe we could write in alphabetical order. First the cos. And then we'll multiply 1 times 1. 1 times cos is positive cos. Negative cos times 1 is negative cos. So we're going to get that positive cos and a negative cos. And then a negative cos squared. Which again, those middle ones cancel out. So if I was to put all of this together, they both have a denominator now of 1 minus cos squared, which I'm hoping you'll see the cos squared in the 1 and be like, oh, that's going to be sine squared by an obvious substitution. And on top, I've got, let's just see, I've got a sine x, a negative cos x sine x, so I'll add the x there, sine x, plus another sine x, plus a cos x sine x. That is a very long numerator. So I can see here that I've got a negative cos x sine x and a positive cos x sine x that will cancel out. And then I've got sine x and sine x, which are like terms, so I've got two of them. 2 sine x over. And this should be an obvious one now, that this is just a sine squared by an obvious substitution, which I'll write off to the side in the key. And then it looks like we've got one of these sines can cancel with one of those. So I've got a 2 on top and a sine x on the bottom, which I don't know what the left is, but or the right side. So if I wanted to, I could push that over and just leave a sine x and a 1. And then sine x is just cosecant x. 1 over sine x is cosecant x. Now, what is the actual right side? Oh, 2 cosecant x. Okay, so that is the right side. So left side equals right side. Okay, so next one. Okay, similar question. I see 2 fractions. You're going to need a common denominator. Obviously, we're going to do the one on the left. So I'm going to rewrite this with a little bit of space so I can multiply by the other denominator to get common. 1 minus cos x. So this side needs a 1 plus cos x, and we'll do that top and bottom. And this left side needs a 1 minus cos x. Now the hope would be that at some point we could multiply these and just know that we're going to end up with a 1 minus cos squared. That the two coses would cancel out. And then that the 1 minus cos squared with an obvious substitution becomes a sine squared. So that's what we're hoping for. That we'll get there. So we can see all of that. So let's multiply the top. 1 times 1 and 1 times cos is just going to be a 1 and a cos. And then down here, we're going to get a 1 positive cos, a negative cos, and a negative cos squared. 1 positive cos, negative cos, and a negative cos squared. And the same will be true for the other side. I need a longer fraction here. So I'm going to have a 1 minus cos. So a 1 and a negative cos. And then make sure get a long enough fraction there. So 1 positive cos, negative cos squared. 1 positive cos, negative cos, and a negative cos squared. And in both of these cases, because there's a common denominator, they are the same, these coses can cancel. So I've got a 1 minus cos of x all over 1 minus cos squared. In fact, they're both the same, so why don't I just put them all together? So I've got a 1 minus cos x plus 1 plus cos x all over the same denominator of 1 minus cos squared. And those can cancel, so all we're left with is a 2 on top. And a 1 minus cos squared is going to be a sine squared. That is the obvious substitution. And I don't actually know, do I need to make that a cosecant? I do. Okay. So this is almost identical to the previous one, in that we're going to push this 2 kind of out of the way and leave us with just sine squared on the bottom, which makes you wonder what's on top. Well, it's just a 1. And 1 over sine is cosecant, but if it's squared, it's just going to be cosecant squared. So this is 2, and 1 over sine squared is just going to be a cosecant squared. And that is my left side equals my right side. So a very similar question. Needed a common denominator in both of those. Merged them together, some things canceled out, and then pushed usually the 2, pushed it over and turned it into a cosecant or whatever it happened to be. And of course we couldn't do that until we first did that obvious substitution, which I'll need to write after. My left side and right side is way over the place. I need to move all of this stuff over. I'll change that after. Okay, let's look at the next one. So looking at this, I don't actually quite know where to start. I mean, turning everything to sine and cosine could work quite nicely, but it doesn't even seem obvious to me which side is more complicated. I don't see any fractions right now, so we don't have to merge two fractions. We don't have a fraction on the bottom of a fraction that requires any flipping. We don't have any conjugate, which again would require a fraction. Now when I look at this, I actually see a couple of fractions. And I see the one that I think I want to do first, and that's going to be this one. So these are all fractions. This is a 1 over cos, and this is going to be a 1 over sine, but they're going to be timesed. So 1 times 1 is 1, cos times sine is sine, or is cosine. It's the other one here that will require common denominator. And the reason it will is because of this plus sign. So that's where I think I want to start with. So tan is sine over cos. So I'm doing the first step, which is just turning everything to sine and cos. Plus cotangent is the flip of that, so that's cos over sine. And now I see two fractions with an addition in between, which will require me to do a common denominator. So I'm going to give myself a little bit more room here. Sine of x over cos of x plus cos of x over sine of x. And I will do a common denominator. So the right side will just need a cosine. And the left one will need a sine. So sine times sine, well, that's just sine squared over sine x cos x plus cos times cos is cos squared. Now, whenever you get two fractions that you get a common denominator, you need to put those these fractions together. That's kind of the whole point. We get a common denominator and we can push everything together. So on top, I've got a sine squared plus cos squared. And I'm hoping that you can see that because they're squareds and there's plus signs, that is one of those obvious substitutions. So over sine x cos x. So sine squared plus cos squared is just 1. I'll write that off to the side, but you can see here, but even we can look at a different one. So this is a different pre-calculus formula sheet, but there, sine squared plus cos squared equals 1. So this is just equal to 1 all over sine x cos x. And that's not what we have. Right? Sometimes it's good to look back at the other side and be like, oh, how do I get there? Well, this is just a 1 over cos, and this is just a 1 over sine. So I see the cos and sine on the bottom. See, sine and cos and sine, but there's two 1s, and there's only a single 1. So if I wanted to, I could split this up to a 1 over sine and a 1 over cos. And that's a sneaky move. So I've got a 1 over sine times a 1 over cos. And you know that works because if you multiplied, you would get this back. So 1 times 1 is 1. And then sine times cos is sine times cos. And then 1 over sine is cosecant x. And 1 over cosine is secant x. And I'm pretty sure that's what I have. Maybe it's in a different order, but that shouldn't matter. Secant, cosecant. So if you wanted to, you could rewrite that as secant x, cosecant x. And then the left side equals the right side.